Hello everybody, it is day 9 of our meteorology unit, and today we're going to be taking a look at how to draw isotherms and isobars, which are going to be contour lines on a map that help meteorologists make sense of all of the data that they get from weather stations in an area, and how they can use that data to predict and forecast the weather that we're going to be experiencing. So let's take a look at some old regions questions. This is questions 76 through 78 from the August 2016 regions. I'll read these instructions. It says the map shows surface air temperatures for some locations in the United States on a day in November. The 20 degrees Fahrenheit, 30 degrees, 40 degrees, and 70 degrees Fahrenheit isotherms are shown. Points A, W, X, Y, and Z represent locations on Earth's surface. The air temperature at location A is shown. So we were talking about station models. Now imagine all these points on the map were recordings from one station model, and they're putting it all in one place, and now we're going to start to draw patterns. These are isotherms, so these lines are connecting every spot on this map that would have a temperature. This line would be 30 degrees. Every location on this map that's on this line is going to have a temperature of 20 degrees. Every location that's located on this line will have a temperature of 40 degrees. And the first question is asking us to draw the 50 degree and 60 degree isotherms on the map. And it will always tell you how to finish off your lines too. Here it says extend each isotherm to the edge of the map. So all lines have to either be closed or they have to extend to the edge of the map. So we're going to take a look at both today. Let's see how we draw these lines. So we can click edit. Now I always tell my students when we were on pen and paper we would just circle it, but since we can't circle on the computer, please don't do that, don't mess up your screen. I'm just going to circle the points where we're going to draw a line through, and then we can take it away later. So I'm going to start with the 50 degree isotherm. So I'm going to circle all of my 50s. Let's make it transparent so we can still see. We can make it a little thicker so we don't miss it. So there's, let's make it a little bit brighter too. So there's one of the points where my 50 degree isotherm is going to go through. Let's see on the map if there are any other 50s. There's a 60. We'll get to that later. Here's a 50 degree mark. And I think I did a pretty good job, but it's the worst when you draw one of these lines and then you see a point that you missed. So it's always a good idea to double check. And it looks like I have all of my 50 degree data points. Now I'm ready to draw a line that's going to connect these 2 points and then extend to the edge of the map. So I'm going to select scribble so I can just draw. And now when I go through the 50 degree data point, I want to make sure that I actually go right through the point. So I'm going to do that. And if there's a 50, I'll go through it. If there is not a number that matches it, I have to go in between the numbers that my value is in between. So if I were starting from this point, 50 is not in between 64 and 61, so I can't go down. That would be incorrect. It is in between, it's not in between 61 and 57. Again, 50 is not that way, so I'm not just going to go here, but this line here is 40. This is marking everything that's a 40. So 50 degrees is in between 40 and 57. So that can be the first place I go with my line. And now I'm just going to stop and I'm going to see where I have to go next. So again, my number is 50. I can't squeeze it between 40 and 42 because that's not where 50 goes. But 50 is in between 42 and 57. So I'm going to continue my drawing just right in between those two numbers. And then again, I'll stop to see where I'm going to go next. So what is 50 in between? Is it in between 42 and 59? Yes, it is. So I can go in between these two and then I'll stop. Is it between 56 and 59? No. Is it between 42 and 56? Yes, it is. So I'm going to continue drawing my line, stop, and take a look around. I see that I have to go through my 50 degree data point here. So I'll extend it to the point. And then remember what those instructions said. We're going to go all the way to the edge of the map. So there's no more values that I have to worry about getting in between there. I'll just go right to the edge. And then we're going to do the same thing down here. All of that work, you don't want to lose that point. So 50 degrees, again, is in between 40 and 64. So I'll go right through that little space. 50 is in between 40 and 57, so I'll continue through those points, and then I'll bring it right to the edge of the map. And through the miracle of technology, I can get rid of those circles from before. So there's my isotherm for 50 degrees. Let's take a look how we would do 60 degrees. So I'll circle my first value here. Let's take a look for any other 60s on the map that we'll have to go in between. Double check, and I don't see any. So I'm going to go back to my scribble line. And let's see, there's no values over here, so I can go right to the edge of the map and make sure that that's done. Now where am I going to go first? Am I going to go between 56 and 59? No. Am I going to go between 59 and 68? I am. I can go in between. 60 is pretty close to 59, so I can go pretty close to that. And where am I going to go next? 59, 63. Again, I can go pretty close to that 59. 60 is pretty close, but I'm going to stop there to see where I have to go. It's not in between 57 and 59. 60 is in between 57 and 61, and it is in between 57 and 63. So I can go through both of those data points. Again, we're pretty close to 61, so I'm not going to go through that dot, but I can go close to it. 60 is in between 61 and 50, so I'll go through those points. We're between 64 and 50, so I can go there. And remember, this is 50 and that's 57, so I can't go between 50 and 57. I can go between 57 and 64, and I can go between that 57 and 64. So I'll go right through those, and then again, remember to bring it right to the edge of the map. And let's clear that off. So that's how we have our two isotherms for 50 degrees and 60 degrees. So now that we have this complete map, we can start taking a look at the different patterns and where the warm air masses and the cold air masses are, and a meteorologist can begin making predictions with the temperature and also looking at a map for pressure and cloud cover as well. Let's take a look at some of these questions from the regions too. So identify the air temperature at Watertown, New York. Well, we can go to the ESRT to find out where Watertown is, and you see that it's kind of on the northeastern border of Lake Ontario in New York State. So here's New York State. We're kind of looking at that top northeast border, and you see it's right around that 40 degrees Fahrenheit isotherm. So I would say 40 degrees would be a good estimate. If you thought, I looked and it looked like it was a little bit over the line to me. So if you said about 41 degrees Fahrenheit, that would be okay. If you said 39 degrees Fahrenheit, again, the Regents allows you to be within a range, and those are within the range of being correct. So those would be fine. And then 78, describe the evidence shown on the map that indicates the temperature gradient between W and X is greater than the temperature gradient between Y and Z. So remember, gradient from the ESRT is the change in field value over distance. So for both of these, they're both on isotherms that are 10 degrees apart. So the change in field value is actually the same for both of these distances between W and X and Y and Z. Each one is changing 10 degrees, only the distance between W and X is shorter. Therefore, we're going to have a greater gradient because we're dividing by a smaller number. And that would be your answer for 78. Okay, we'll make another video for isobars in just a second, but this was isotherms showing us thermal energy.